TXCK Pure Maths, May, June 2019, paper 2, past paper. All right, let's get right into it. Now, question 2 says, let A equal a set of X such that X is a member of the real number system where X is greater than or equal to 1. A function f is such that A maps onto R is defined as f of x equal x squared minus x. Show f is 1 to 1. Now, before I even get into that, let's try to understand this question here. A here represents my domain, R represents my codomain. So it's saying that A maps onto R. So A is your input, R it represents the outcome, your codomain. But please understand that the codomain and the range are different. All right, the range is a subset of your codomain. Now, first of all, this is a quadratic function. We know that by nature, quadratic functions are not one-to-one. Good? Because guess what? One way to test it is to use a horizontal line test. If I take a quadratic function and I draw a horizontal line, this horizontal line is going to cut the function twice, which makes it not one-to-one. But if I restrict the domain of my quadratic function, probably I look at it at about the turning point, then of course the horizontal line is going to cut it once, making it one-to-one. So there are two approaches that we can take this question with. We can take a graphical approach, or we can take it from an algebraic perspective. The graphical is easier to see. So we're going to go ahead and sketch the function. Now, sketching a quadratic function, of course, would require me to complete the square. So I'm going to have x, which I'm going to, f of x, which I'm going to express in the form a into x plus h all squared plus k. Now, using h, the simple formula is b over 2a. So my h value from here, a is 1, b is -1, and c, of course, is 0. So h would be -1 over 2 times 1. H would be -1/2. So that's done there. Now, k is equal to c minus a8 squared. C is 0, a is 1, and h is -1/2. Good? So this is going to boil down to give me k equal 1/4. All right, so that's wrapped up over there. We're done with that. Now, f is therefore going to be a, which is 1. We don't need to put a 1 out there. So we're going to have x minus 1/2 all squared minus 1/4. Now, I need to sketch this function. Now, first of all, I need to know where the turning point of this graph is. The turning point is at -h and k. My h value is -1/2. So it's going to be at +1/2 with my k value, which is -1/4. So we have taken care of that part. Now, let me get in and try to sketch this function. Let's say we put a half right here. Now, please remember to label the axes x and y. All right, -1/4 about there on the y-axis. All right. Now, since the c value is 0, the graph is going to cut the y-axis at 0, which is going to be right here, which means it cuts the x-axis at that one point as well. But it's also going to cut the x-axis somewhere else. How do I know that? I equate the entire function to 0. All right, we can factorize this. Two things multiply to give you one of them must be 0. So x must be 0. Or we can say x equal 1, right? X minus 1 is 0. So we know it's going to cut it at 1 as well. Now, let me use a different color. So here's my turning point. And so my graph is going to go right through here. And it's also going to go right up there. And try to make it as smooth as possible. Now, if I draw a horizontal line here, then that horizontal line is going to cut the graph twice. But notice that I can't just do that because there's a domain. The domain says that x must be greater than or equal to 1, which means I'm going to have to come here where I have 1, and the part of the graph to the left of 1, which is less than, all of that will go. That's what we mean by restricting the domain. So I'm going to take out all of this. All of this will go. All right. Now, let me label because you can't do this without labeling. So this is your graph, f of x. You're now going to draw your horizontal line. So this is my horizontal line, which cuts the graph once, which makes it 1 to 1. are injective. Please remember that. That's a word that also means one-to-one. So now I'm going to have to write my concluding statement that since the horizontal line cuts the graph once, then f is one-to-one or injective, QED. Good? All right, you can just write that there. All right. Very important. I'm simply going to move to the next question. You can, however, write in the statement. That is going to be a very important statement. And you'd have gotten 7 marks there. All right. This is question B. It says f of x is equal to 3x plus 1 and g of x is equal to e to the x. Now, since no domain is given, we have to assume that the domain is actually the real number system, f inverse of x, which of course not so difficult. Persons normally like to start by saying let f of x equal y. Nothing is wrong with that. So y equal to 3x plus 1, and then we're going to interchange x and y. So we interchange x and y. So you're going to have y equal 3x plus 1. This entire process really not so complex. It's just easier to use y. And you have to remember that really and truly, f of x really means the same thing as y. So, because y is your output, f of x is also your output. All right, so I'm supposed to interchange x and y. Oh, let me just remove this. So when I interchange, it's really going to become x equals 3y plus 1. And then we transpose back for y. So x minus 1 equal to 3y. X minus 1 over 3 is equal to y. And then, of course, therefore, f inverse of x is equal to x minus 1 upon 3. Now, let's see how much marks they gave you for that. That was 2 marks. Now, look at this now. It says f inverse of g. The small o there means of. So, how does this work? What it means is that you're going to take your g function and you're going to plug it into f inverse in the place of x. So remember now, f inverse of x, we just did it up here, was equal to x minus 1 upon 3. So let me just put it back here. G of x, if you go back up, was equal to e to the 3x. That's it. So g of x is equal to e to the 3x. So I'm going to put the g function inside the f function in the place of x. So f inverse of g, and the small o means of, is equal to e to the 3x minus 1 upon 3. That can't be simplified, so I mean we're going to leave it right there. All right, so you have 2 easy marks there again. All right, it's going down now. Solve, and this is question C. Solve equation 3 minus 4 over 9 to the x minus 4 over 81 to the x equal to 0. Now, if you notice that 81 is really the square of 9, which means in my head, I'm thinking that this must be a hidden quadratic where you have one expression, which is the square of the other one. So I'm going to go 3 minus 4 over 9 to the x. By laws of indices, I can write this as 4 over 9 to the 2x is equal to 0. So we can say 3 minus 4 over 9 raised to x minus 4 over 9 to the x squared. Again, by laws of indices, you must know your laws of indices. Now, because these two things look alike, this is grounds now to use a substitution. And believe me, this topic, it comes in a lot of modules, substituting something that reappears to make it simpler. So let u equal 9 to the x. So 3 minus 4 over u minus 4 over u squared is equal to 0. Now, what's the one thing that we don't like when solving equations? We don't like to have denominators. So we multiply by the LCM, which is u squared. So you're going to have 3u squared minus 4u minus 4 equals 0, which takes me exactly where I want to be at a quadratic equation. 3 times minus 4 is minus 12. Now, the two numbers that will multiply to give me minus 12, but when I add them, I'm going to get negative 4, would be negative 6 and positive 2. So you have 3u squared minus 6u plus 2u minus 4 equals 0. You know the step, you pair them off. 3u, u minus 2, plus 2u minus 2 equals 0. So 3u plus 2 equals 0, or u minus 2 equals 0. Some persons would feel like they're finished when they say u equal to negative 2/3 or u equal to 2. No, can't be. You're never supposed to find u. You were supposed to find x. So recall the substitution, 9 to the x equal to u. 9 to the x equal negative 2/3. 9 to the x equal positive 2. Now there's something wrong here because there's no way I can take a 9, positive 9, raise it to a power, and I end up with a negative. This is impossible, so not applicable there. On this side, you have 9 to the x. Laws and indices can't work, so we're going to have to rely on either log or ln. So we can convert directly this to log form, where we say log of 2 base 9 is equal to x. Therefore, x equal to log of 2 base 9. And if you want, you probably could write it as to 3 significant figures, which is required by your syllabus, right? But I'm going to leave it as that, which is the exact value. All right, going good so far. Now, the less time you can use, the better it will be for you. Question D in my module, symmetry of roots of equations. Now, when doing this topic, you have to focus. You have to be very careful because at times you can make some very simple mistakes which you don't want. All right, so let's see what happens here. It says state the value. Now, all these have formulas, so you can't go wrong. Alpha plus beta plus gamma. These are cubic equations, and they're going to have 3 roots. We know is equal to minus b over a. The pair, the sum of the pair, the root, some of the roots pairwise is equal to c over a. So alpha beta plus alpha gamma plus beta gamma is equal to c over a. And alpha beta gamma, which is the product of the roots, is equal to minus d over a. So you have sum of roots, sum of product of roots pairwise and product of roots. Now my b value, go back here, a, b, c, d. My b value is negative 5, and my a value is 2. So it's negative 5 over 2. My c value is 4, so I'm going to have 4 over 2, which is 2. And my d value is 6, so I'm going to have, by the way, this says negative b over a, right? So there will be 2 minus signs here. So I'm actually going to end up with a positive 5 over 2. Please pay keen attention to that, because that's an error persons normally make. So here I'm going to have, since d is positive 6, I'm going to have minus 6 over 2, which is minus 3. All right, so all this is taken care of. Now let's see how much marks they're going to give us for that. 3 marks, 3 easy marks. Of course, you know you're going to need this for the next part of the question. 5 over 2, 2 minus 3. All right, so let me just put them here so you can see them. The sum is equal to 5 over 2. Pairwise, sum of product pairwise is equal to 2. And of course, the product is equal to minus 3. Let me just go back up quickly and check that. Because you know this question will never come without a part B. All right, so let's get right into it. It says determine the equation with roots alpha squared, beta squared, and gamma squared. Now all equations, all cubic equations take the same form. X cubed minus sum of roots times x squared plus product of roots pairwise. All of that multiplied by x minus product of roots equals 0. All right, so sum of roots, product of roots pairwise minus the product of the roots equal to 0. So I'm going to have x cubed minus this. The roots here are alpha squared, beta squared, and gamma squared. So alpha squared plus beta squared plus gamma squared times x squared, the product pairwise. sum of product pairwise. So alpha squared beta squared plus alpha squared gamma squared plus beta squared gamma squared times x. So you're multiplying them in pairs. Minus the product. So minus alpha, beta, well, alpha squared, beta squared, gamma squared equal to 0. Now, let's take this step by step. Now, alpha squared plus beta squared plus gamma squared. Now, don't mix this up. This is not the same thing as alpha plus beta plus gamma squared. All right? But you have to use that in order to get this. So what we normally encourage persons to do is to commit to memory. Well, here you have it on the paper. You don't even have to do anything. Here's the formula that they gave you for it. It's best to commit this to memory because they don't have to give you. So alpha squared plus gamma squared plus beta squared, it doesn't matter the order, is equal to alpha plus beta plus gamma all squared minus 2 times alpha beta plus alpha gamma plus beta gamma. Guess what, guys? We found all of these already. Alpha plus beta plus gamma was 5 over 2. So it's 5 over 2 squared minus 2 times the sum of the product pairwise, which in this case was 2. And of course, all of this is calculator work. All right. Probably I can sectionalize this, eh? Let me put this over some more because I'm going to need some more space here in the middle. Probably can carry it all the way over here. Now, as you can see, they gave you the formula for this too, because bear in mind, alpha squared beta squared is the same thing as saying alpha beta all squared. Alpha squared gamma squared is really alpha gamma all squared. Beta squared gamma squared is really beta gamma all squared. And the formula they gave you is this right here. Alpha beta plus alpha gamma plus beta gamma all squared minus 2 alpha beta gamma times alpha plus beta plus gamma. And guess what, guys? Even if they don't give you the formula for this, you can actually use the formula over here to get it. Because all you do is replace alpha with alpha beta on both sides, replace gamma with beta gamma on both sides, and replace beta with beta gamma on both sides. Okay, so let me just populate this formula now. The sum of the product pairwise was 2, so that's 2 squared minus the 2 times the product, so 2 times negative 3, times the sum, which is 5 over 2. Now, you don't need to work this out step by step. All of these are calculator work. Now, since I have the space over here, let me just put in the final thing that I need. You also need to have alpha squared, beta squared, gamma squared. Laws and indices come in handy because this is the same thing as saying alpha, beta, gamma all squared. This is really alpha, beta, gamma was found to be minus 3. So it's minus 3 all squared. Now, this is where you need to pull up your calculator and allow your calculator to do the work for you. So you don't have to do too much here. Let me start by putting this over here. So I'm going to have open bracket 5 over 2 close bracket squared minus 4. That's 9 over 4. All right, we can also put this. All right, let me just write it down. So this is 9 over 4. Put that down there because we have that already. All right, let's go and put in the middle piece inside of the calculator now. So that's 2 squared. That's 4. You don't have to put in something you can work out inside of your mind. Like how I know that this part is really negative 2 times negative 3 is positive 6. All right, but if you feel you're going to be nervous in the exam, you can go ahead and put it in 5 over 2. That's 19. So this is 19 right here. And of course, this is 9 over here. So let's go back to the formula and plug in what we found out. So it's x cubed minus 9 over 4 x squared plus 19 x plus 9 equal 0. This should be minus 9 right here because it's minus plus then minus. All right, so pay keen attention to these things, guys. Now, this equation seems a bit awkward. What do I mean by that? This equation has in denominators, which you don't want. It doesn't look cute. All right, because we want the coefficients to be integers. So we're going to have to multiply everything by 4. So I'm going to bracket all this, and I'm going to multiply it by 4. Now 4 times x cubed is 4x cubed. So it's going to be minus 9x squared, and the 4 would have canceled out the 4 here. Then I'm going to have 4 times 19. All right, let me just quickly, and of course, once again, if you think you're going to get it wrong, put it inside of your calculator. 4 times 19. 76. So plus 76x, 4 times 9 is 36, minus 36 equal to 0. And there you have your cubic equation with the roots alpha squared, beta squared, and gamma squared. Right, let's see how many marks. So that's the end of question 2. And you'd have gotten your 25 marks. All right, very good so far.